So this rug has an accent border, and statement 2 tells me that it's the same width all around, 1 inch. And what I'm thinking is, if I want to find the area of the rug excluding that border, I kind of need to know the shape of the rug. I mean, I know it's a rectangle, but is it a very skinny, very long rectangle, or is it a rectangle that looks a bit more like a square? And as I look at these statements, even if I combine them, I have no idea. And I feel like it should matter, right? If this rug is a square, I mean, a square is a kind of rectangle after all. If it is a square, that would lead to one answer. And if it's the opposite of a square, in other words, if it's very, very, very long and skinny, that would lead to a different answer. So I feel like I should be able to pick E without even using pen and paper for this question. And I guess the concept that I'm using to be so confident about my answer here is that the closer a rectangle is to a square, the greater its area for a given perimeter. And you can play around with that a bit, maybe draw some rectangles on your paper and see what happens to the area as your rectangle gets closer and closer to a square. In the extreme, you have a rectangle whose width is close to 0. And if the width of the rectangle is close to 0, then it doesn't even really matter how long it is. The area will be close to 0. Now, if you take that same perimeter, so it might be a very, very large perimeter, because the length of the rectangle could be the length of the equator, right? It could be a very long length. But if you use that same perimeter in a more even manner, so imagine the length and the width are equal to one another, also known as a square, then obviously the area would be much greater. So when I look at these statements, I can't tell whether this rectangular rug looks more like a super skinny rug that has an area close to 0, or a square that will have a much bigger area for the given perimeter that they're giving us in statement 1. And that's why I'm so confident that even when I combine these statements, I can't possibly answer this question, and the correct answer is E.
If you found this video useful, go to quantreasoning.com for a lot more where that came from. You should also click that like button and let me know in the comments below what you'd like me to make future videos about. And of course, if you haven't yet subscribed, go ahead and do that and click that bell below so you get notified about future videos. See you next time.